What's up everybody? In this video, we are going to learn how to use an LED to create a visual indicator that your robot is thinking. To be honest, we are creating this more for the humans watching the robot than we are for the bot. As you've experienced through the coding of the Arduino, the brain of your robot, it can make calculations in microseconds. As such, it works at a level that is faster than most of us can comprehend. The LED helps us see what the robot is doing. So how will we do this? We are going to flash an LED quickly through a series of values. While nothing is actually happening, it will look like something is. Essentially, it will provide feedback and look like the robot is thinking about what to do next. Start off by logging into Tinkercad using your course username. Select Circuits in the left-hand menu. You will see our motor driver distance indicator sketch. Hover over the circuit and click Tinker This. Below the getDistance function, type the following: void, thinking, open bracket, int, blink speed, comma, int, how long, close bracket, open curly brace, close curly brace. We created a function called thinking that accepts two parameters, blink speed and how long. Blink speed will control how fast the light flashes, and how long will control how long the robot thinks. Next, inside the curly braces, add set speed, open bracket, 0, 0, close bracket, semicolon. This will tell the robot to stop moving. After all, we want to create a dramatic pause and focus the attention to the LED. Inside the thinking function, we want to write code that will iterate and execute as long as certain conditions are true. We can use a for loop to do this. Type for, open bracket, int time equals 0, semicolon. Time is less than or equal to how long, semicolon. Time is equal to time plus blink speed, close bracket. Open curly brace, close curly brace. We initiated a for loop, and inside the brackets, the first parameter is the initialization. This happens first and only one time. In our loop, we create a variable, time, and give it a value of 0. This is because we are starting the count for how long we want the loop to last. Next is the condition. Each iteration through the loop will check the condition and will only execute if it is true. In our loop, it will check to see if the value of time is less than or equal to how long. The parameter we pass for how long the robot will think. Last is the increment. This is executed each time through the loop when the condition is true. So each time, it will add the value of blink speed to time. To determine how bright the LED is, we will make use of random values. Since the LED is an analog output, the value can range between 0 and 255. Type int rand value equals random, open bracket, 256, close bracket, semicolon. Here we just created a random number for the LED value and called the random function to generate a number. Next, use the rand value variable as the value for the LED. Type analog write, open bracket, LED pin, comma, rand value, close bracket, semicolon. Last, we want to add a delay. Type delay, open bracket, blink speed, close bracket, semicolon. We use the blink speed delay to determine how fast the LED will change based on a delay value. Last, we will turn off the LED after it is done thinking. After the for loop, add analog write, open bracket, LED pin, comma, 0, close bracket, semicolon. Now all we need to do is call our thinking function when we want to use it. Go to the setup function and type thinking, open bracket, 50, comma, 2500, close bracket, semicolon. Click Start Simulation and you will see the RGB light cycle through random colors during the setup function. Remember, the setup runs once when the Arduino starts. Essentially, before the robot starts moving, it will think for 2.5 seconds. Let's find another time that our thinking function would work well. Go to the avoid collision function. After backward, add thinking, open bracket, 50, comma, 2500, close bracket, semicolon. This will give a reaction after the robot is about to hit something. It will back up as an immediate response, then it will think, turn, and go on its way. Click Start Simulation and test out the sketch. Great! Now it looks like our robot is thinking as it encounters obstacles. This is good, But let's add one more edit to try and make the behavior seem real. We can add more randomness to the sketch to make it look less predictable. Right now, after the robot avoids a collision, it thinks for the same amount of time and always turns in the same direction. So while we have the thinking and flashing of the LED, the robot always thinks for the same amount of time and has the same response, which is not very natural. We want it to look like it's trying different things. Let's randomize how long the robot thinks. In the avoid collision function, right before the thinking function, type int how long equals random, open bracket 500, comma 5001, close bracket, semicolon. You may have noticed this time we passed two parameters to the random function. The two parameters passed are the minimum value and the maximum value plus 1. If the minimum is 0, we do not need to put a number. Change the second parameter in the thinking function to how long. Next, we will randomize which direction the robot turns and for how long it turns. Type int ranDirection equals random, open bracket 2, close bracket, semicolon. Then int rand turn amount equals random, open bracket 500, comma 1501, close bracket, semicolon. We now have two random values. The ranDirection will pick a number between 0 and 1. We can use this to randomize which direction the robot turns. Type if, open bracket, ranDirection equals 1, close bracket, open curly brace, close curly brace, else, open curly brace, close curly brace. Inside the first set of curly braces, type left, open bracket, 255, comma 255, comma rand turn amount, close bracket, semicolon. And inside the else curly braces, type right, open bracket, 255, comma 255, comma rand turn amount, close bracket, semicolon. Click Start Simulation and test your sketch. You should see the functions working. This will be much easier to see when you upload the code to your robot. One last note, the values we use are starting values. You may need to adjust some of the random min and max values on your robot. At the end of this video, you should have a better understanding of how to use random values to create a thinking behavior for a robot.